talk about the calculation of the pH of a very strong acid. Of course, a strong acid, we all know, dissociate completely, and a strong acid is determined by the equilibrium position, and the equilibrium position of a strong acid solution lies far to the right. Why? Because such an acid will dissociate finally until the concentration is 0. And in calculating the pH of a strong acid, we must determine the major species. Now let's look at the calculation. Calculate the pH of 0.1 molar, which is mole per dm cube of HNO3. Now, if you look at this, the major species are H plus, NO3 minus, and H2. But there's a principle. The H2 is ignored because HNO3 is the major source of H plus. Of course, H2 produces H plus, but it's not considered because the concentration of the proton produced by this H2 is quite smaller to the concentration of the H plus produced by HNO3. So we must only consider HNO3. So if we break that down, we have HNO3 to give us H plus and NO3 minus in an aqueous solution. Now the initial concentration of HNO3 is 0.1 molar, but the initial concentration of H plus and NO3 minus is 0. Why? Because this is the initial, and before we can produce this product to have a particular concentration value, we must have an initial value which will later decrease to produce a certain value of this product. So by the time this reaction begins to occur, we have a change, and that change is negative because the concentration of this reactant will decrease. So we have minus 0.10 and plus 0.10 plus 0.10. Why am I confident that this should be 0.10? It's because I am very sure that a strong acid will always dissociate completely, which means that the concentration of this nitric acid is completely converted to 0.1 molar of H plus and 0.1 molar of NO3 minus. So by at equilibrium we have 0 molar. You can see that the 0 here indicates that this HNO3 has dissociated completely. So but we are concerned in the calculation of pH value of H plus in this reaction. So by that you see that our pH equals to the negative logarithm of this H plus, which is 0.10. By the time you punch that into your calculator, you have 1. All right, so to calculate the pH of 2.5 times 10 to the power minus 3 molar HCl solution, of course, since hydrochloric acid is a strong acid, we have the same issue there. The initial concentration 2.5, also 0 because they have not yet been produced. So the change comes about having a negative value here and a positive value. So I want you to note that this positive value means that there is an increase in the concentration of the product, while this negative minus means there's a decrease in the concentration of the reactant, which makes it an equilibrium reaction. So we have H plus, and we can find our pH value in our calculator. We have 2.60. Thank you very much. If you have any other comment, send it to my WhatsApp page. God bless you.